you. All right, so in case you haven't guessed from the slides, we're going to be talking about browser secrets today. So I don't think we really need to go over this, but the main takeaway here is that I am not Julia Stiles.
Some of the just interesting things here is, like it says there and in my bio there, kind of a high voltage junkie. I like to do a bunch of different things, from Tesla coils to plasma speakers to all sorts of different things like that. So that's just kind of my fun side thing other than information security.
All right, so browsers. This is obviously a post-exploitation talk. Somehow, some way, through magic, you have gotten an initial foothold on an end user's computer. And so the big question becomes, how do you go from here to here? Because the whole point is you want to burn it down from the inside, right?
You want to make him think that they're burning it down from the inside.
Okay, maybe not literally, but that's always where you want to get. So one of the best ways to do this is with lateral movement. Now, there's a lot of different ways to go about doing this, and I'm not going to touch on really any of those during this talk. We're just going to be talking on browsers. So browsers are excellent. They are gateways. They let us access the public internet and all the amazing, fun cat memes that you can find out there. But they also are great for organizations to give end users access to very sensitive services and interfaces. So in order to do that, they're going to be giving these users credentials, and when they authenticate, they get cookies. And so browsers house these cookies, and the question is, how secure are those? If I get access to your laptop, how secure are those cookies? Can I actually take advantage of it? And then also, all these major browsers, as well as others, now include password managers, which is really fun and awesome and really convenient for the end user when you're authenticating to these services. But then the question becomes, how secure are those credentials? Sorry. Is that me? Are we good? All right, cool. So, secret storage practices. I can turn off my mic.
No, that's me, sorry.
Oh,
actually, maybe turn off that one.
Oh. Okay, cool. We're good. So, talk about secret storage practices. First up on the chopping block is Firefox. So Firefox, this browser is really great. It's open source. The Tor browser is actually based off of it. So one would think that they take security, at least from the end user's standpoint, pretty seriously. Suffice to say, I was pretty disappointed, and still disappointed, this isn't news, that they are still storing cookies in plain text, in SQLite databases and in JSON files, JSON-ish files. And the reason why I say ish is because they're only JSON, like straight JSON, when you're on a Linux flavored distro, right? If you're on Mac or Windows, they actually compress it using LZ4. Why? I don't know, but they do. But if you just throw this file as is at an LZ4 utility, it's going to bork. Yeah? No, it should be on.
Mine's been the one that's been causing the problem, see? So that's why I've been leaving it off. Where's the speaker?
Right here.
Yeah.
Do I need to move?
Right there. That's why.
Are we good? All right, technical difficulties gone. All right, so back to the LZ4 compressed recovery JSON file. This file actually stores authenticated cookies, so it's going to be super interesting to you as a penetration tester. But if you just throw the compressed file at a utility, it's going to bork. And the reason for that is Mozilla, for whatever reason, decided that they were going to add a magic number, like pre-pinned the file with a magic number. Very easy to bypass. You just get rid of the magic number, throw it at the utility, and it decompresses it fine. But I mean, even if, for whatever reason, you don't have that available, and I guess you can't really see because it's going off the screen. But believe me, there are cookies over here, and you can read New York Times. So there's real session cookies in that file, and they're very easy to see. It's Vim with XXD because I'm a Vim junkie, so deal with it. All right, so just to make it a little clearer, this is an authenticated session with GitHub. And the top here is catting out the recovery JSON file. And then below, we've got the SQLite database. And as you can see, the authenticated cookie, the one that's actually going to get you gold, is in the recovery file. And then you've got several other cookies that GitHub returns once you've authenticated, and those are in the SQLite database. So all plain text. There's really no bar there, except you got to get onto the system to get access to them. So they fail in cookies. With passwords, they seem to be doing just a little bit better. So the way that password storage works on Firefox is it takes your credentials and it's going to store them in one of two files. One of them is going to be logins.js, or they're going to be storing it in a SQLite database, sign-ons.sqlite. I have no idea why they keep going back and forth between the two. It's really strange instead of just choosing one file and going with it, but this is what they do. These credentials are encrypted using what they call a secret decoder ring key and salt. And those values are stored in the key3 database. Ideally, they're going to be encrypted because the user has set a master password. And so theoretically, this sounds pretty good. It should be pretty decent. This designed the overall scheme here just to make it a little more clear. It's not something that I put together. Totally stole that from RaiderSec because he's got a great write-up on this. But thought I'd include it to make it just a little clearer. All right, so first demo. So this that we go through, it'll play. This is initial install for Firefox, just to validate whether or not they set up, or they prompt the user to set up a master password upon the initial configuration. So the first time that you authenticate to a site and it asks you if you want to save credentials using their password manager, one would hope that they're going to walk you through also setting up the master password, since that's like the key component to ensuring that this entire encryption scheme is going to be secure. So we're getting there. And I'm going to look for GitHub using Yahoo, because for whatever reason they default to that. I don't know why. I'm really not a fan of Yahoo, and I'm sorry if there's anyone in the house that works for them.
I'm not.
No judgment. So signing in, and this is a throwaway account. You're going to see the password to it later, which is super secure. Have fun. I did this very late at night, flying in from the East Coast, so that's why it's a little slow. I apologize. And we sign in. All right, so it asked if we want to save the password, but there's no prompt asking for the master password or to take me through it on the initial configuration, which really renders the entire thing null and void. And it's super disappointing. So no master password set on initial configuration, and as you can see, just taking a simple script and decrypting it, since there is no master password, and a lot of users do not configure master passwords. It's arbitrary to recover these credentials. So when we're scoring them, and we will be scoring them as we get through, Firefox epically fails on cookies and only has a semi-pass when it comes to passwords. Well, semi-fail, I should say.
Doesn't it also have problems with if you uninstall and reinstall it later?
Yeah, if you uninstall it and reinstall it, it doesn't delete any of the databases, but I believe that that's more of a user, excuse me, if you have an issue with the application and you do need to reinstall it, you're not going to lose your entire database, but that's just something to be aware of. If you're going to be sharing computers, you want to truly wipe it.
Or if you are a pen tester and you don't happen to see Firefox installed at the time, still check for the cookie files.
Oh, yeah.
They could still be there.
True.
You just don't know.
Absolutely. All right, so next up we have Safari. Safari's put out by Apple, and Apple seems to have takes security pretty seriously, so one would hope that that would be reflected here as well. Unfortunately, that's not the case. The file that it's stored in is a cookies.binary cookies file, and as you would guess from the name of the file, it is a binary format, proprietary binary format. There's no official documentation on the actual format of this file, but it's arbitrary to reverse and to figure out exactly oh, wow, I have an echo now. Exactly what's going on with it. And there's tons of people that have actually looked into this. There's scripts available. One of the better ones is the binaries cookie reader to use to recover these files. And again, you can't see, but if you just throw it into XXD, you're going to be able to see the cookies as well. So they are stored somewhat obscurely, but again, not encrypted. So it's really security by obscurity that is highly ineffective.
I wouldn't even really say that this is a security by obscurity at its finest.
Tongue in cheek.
Yeah, of course. Because a lot of what ends up happening in this is just the way that they've organized it. You can tell that either somebody that put this together came from like a really heavy C or COBOL background, because they're really focusing on just the way that the data structure is set up. And like that's the thing that matters to them. And it's actually really, really interesting and cool, but it's not exactly saving as much space, I don't think, as they think it does. Yeah. It happens.
So there you have it. All right, but with passwords, Safari actually does a lot better. So Safari uses the built-in keychain utility to store passwords, but it goes one step further. Instead of storing it in the login keychain, which is up there at the top, well, you can't see. My screen's too wide. There's a login keychain up at the top, for those of you who aren't familiar with the keychain utility. And that's the keychain that most applications, third-party applications, if they're going to make use of the keychain protocol, will be storing those credentials or whatever secrets that they're storing in. Safari stores them in local items. Now, the reason why this is good is because there is a command line utility that's called security, command line utility that you can use to access the keychain. You can't list out the local items keychain when you just try to list whatever keychains it has access to. It's not included. So that's one thing right there that's good. It's defense in depth, makes it that much harder for a pen tester to get access to it. But in addition to that, since they're using it in the keychain, you have to have the user's password to recover these credentials. So you can't just dump it through a keychain bypass. You need in addition to the user's password, you have to actually be able to get access to that local item. So if you only have CLI access, you're kind of screwed. So when it comes to passwords, they definitely are doing good. They have a great success rate on that, but they just epically fail with the cookies, which in the end, if you've got one or the other, it's a win. So next up, Internet Explorer, that you can't see at the edge. But that is Internet Explorer and Edge. We're just going to lump them all together. Just like all the rest of the browsers, they too store in plain text because that just seems to be the running trend. They store them in arbitrary areas all throughout the operating system. So it does make it just a little more difficult to find them. And then the actual files themselves, it's a hash that they're named with, and I think it's like a hash of the whatever site or application that it's targeting. But it's a hash that they're using and then .cookies. So there you go. But if you throw it into Notepad or take it off and throw it into Vim, it's all plain text. It's really easy to recover those. So no surprise there. They do a little bit better with their password storage and more emulating Safari in the sense that they're trying to make use of the built-in credential storage utility that they have. And theirs is called Vault. So this is really good when it comes to application-to-application attacks. So an application that doesn't have permission to see said credentials is not going to be able to use the Vault to gain access to these passwords. But if you have access to the endpoint in the context of the user, or you have a process that is running in the context of the user, you're totally going to be able to pull these credentials. There is no prompting to ask for the user's password just to ensure that you are who you are, that this isn't a malicious process. So that is a fail on that, but not necessarily with Internet Explorer and Edge. We're going to pretend that Microsoft didn't design all of this. But that's a fault with the operating system and the fault with the way Vault is designed. So as you can see here, I've got the Lazane project, which is a great utility for recovering passwords for all kinds of operating systems, Windows, Mac, Linux, but was able to recover them successfully for Internet Explorer for that GitHub site that I actually, well, you saw me access through Firefox earlier. Now, there's a lot of different modules that you can use for this. The reason why I went with Lazane instead of the more popular PowerShell script or PowerSploit Empire is because when I was testing this, it borked when it was trying to decrypt the password for whatever reason. I just didn't have time to sit there and troubleshoot, which oftentimes when you're on a pen test, you don't have time to sit there and troubleshoot. So you just go to the next best thing. And in this case, it was the Lazane project.
That's not entirely true. What actually happened was she got really angry at Windows and started screaming about it and then just said, I'm using this instead. It was the right decision, but...
That's part two.
Yeah.
I'm not a huge Windows fan. I know how to break it. I don't really know anything else about fix it. So there you go. So when it comes to Internet Explorer and Edge, we've got a semi-pass and 2 fails. Chrome does a much better job. And that's really not a surprise, at least within the security community. Chrome has an excellent, stellar reputation for taking security seriously. Just Google itself is pretty good when it comes to security. So they too store them in SQLite databases cookies, but they are encrypted. And they're encrypted in a similar manner that the passwords are encrypted too, that we will get to. And they do a decent job. The better job is on Mac, in my opinion, but they do a decent job all around. So with Windows, they're using the crypto API, which again isn't the best, but it's more of the issues with that lie back on the operating system itself and the way the API was designed, not necessarily in the design that Chrome uses to encrypt these cookies. So they're stored in a SQLite database and they're encrypted. Linux is the only one where it's a little funny. So with Linux distros, it just depends on the flavor that you got, whether or not there's a password manager that is installed by default. If in your distro you have, KDE, the K-wallet, as well as the GNOME keyring. If one of those is installed, then Chrome is going to automatically use that. It'll generate a random value, 16-byte value, key, and it will store that in one of these third-party password managers, and it uses that value to encrypt all the cookies against. So that's great. That's pretty good. Again, it's arbitrary as long as you're running a script within the user's context to gain access to that value, but the point is they're trying to make you work a little harder to get access for these values. Thing is, if there's no third party or there's no password manager on the system, then the value that they use to encrypt all the cookies against is peanuts. Static, uniform, all across the board, which is a little disappointing. One of the ways that you can tell whether or not it's been encrypted using peanuts or if it's been encrypted using a random value is, I've got it highlighted below here. This is a SQLite database. We're just accessing it, so we can see that the sessions themselves have been encrypted, but I don't know if you can see in the back, v10 is prepended to it. If v10 is prepended to it, that means that there's no password manager on the system, and it's encrypted using peanuts. If it's v11, there is a password manager, and so you're going to need to dump from the keyring or the wallet or wherever that value is in order to recover those sessions. So passwords are stored in the same way, but the only difference with Linux is that, and I think I said that they encrypted it with peanuts before, but they don't for passwords. With passwords, they actually store it in plain text if there's no password manager on the system. So, which that's a horrible fallback, and I'm not sure why they chose that, but they did. So with Mac, so I said before that they do a random value and they store it in the login keychain as Chrome Safe Storage. So the one caveat with storing things in the keychain is you need to set the ACLs correctly. And if you don't set the ACLs correctly, this is actually a reported vulnerability to them. That means that if an application has been installed prior to, or even after it exists, it can ask for permissions to that, or it can create the value. So, and that would mean that Chrome uses it, and theoretically, if other things aren't set up correctly, that application is going to have access to all of your session tokens and as well as your credentials. And that's kind of a scary thing. But this isn't as bad as it sounds, and the reason for that is because Mac is a sandbox. But there's a lot of applications that actually make use of this. So Vivaldi is one of these browsers. I don't know how many of you have heard of it, but they are one of the browsers that like to register the Chrome Safe Storage value within the keychain. And as you can see here, I've done this before Chrome is actually installed on the system, but we have a Chrome Safe Storage key already present in the keychain. So when you install Chrome, it's going to ask to get access to that specific value because it thinks that you've already had Chrome installed on the system. And so it doesn't want to negate you or remove you from getting access to the previously created passwords and credentials that you have stored. That's really shady and really questionable, and Vivaldi's bad for doing that. If you look on the forums, people are asking about, why is Vivaldi asking for access to my Chrome Safe Storage cookie? And their explanation is, well, this is for a future feature that we've got going on, but we just happened to choose the same name as Chrome did, so it's okay, it's safe, ignore it, you can just accept it, it's fine, which that's cool. It's not that big of a deal, though, in this respect, and that's only because within Mac they built in the operating system. Every application has its own sandbox, and so applications themselves have very limited access to the file structure. And so I didn't, as you can see, when I've listed out the files that have the @ symbol appended to the permissions structure, that means that it's protected, it's quarantined. And in a sense that only the application that wrote or created that file is going to have access to that file. And so the cookies file, this is where your cookies are with Chrome, it's under quarantine. The login data, this is where your passwords and other credentials are stored, is under quarantine. So even though Vivaldi has registered for Chrome Safe Storage, theoretically, unless there's some kind of breakout, they aren't going to be able, from the application, get access to these credentials. But just to play it safe, don't use Vivaldi. So we come back to Chrome definitely is in the best position when it comes to safeguarding your secrets. But the whole current state of browser security is pretty sad and pathetic. If you get access to a machine, you pretty much have access to the world. And yes, this is true for a lot of things, but one would hope that there would be a little more hoops that you would have to jump through to gain access to further services within an org. At least from this standpoint, there isn't. So now we get to talk about secret extraction techniques. I love this GIF with the slow. It's just so epic. So, I could look at that all day. All right, so talking about browser passwords, and then we're going to talk about the tool that we created. So with password extraction, I've got a few lists here, and you really can't see it because it's going off the screen, but if you want to see the slides later, I'm more than willing to share. It's not a comprehensive list, but these are just some of my favorite tools to use. And they're really excellent and good on all operating systems with pretty much all these different browsers. This is just a keychain bypass that I used on an older version of Mac. Super, super easy to do, and we actually included it in the tool that we have. But here's the Chrome safe storage value, and so that's the value that you actually use to decrypt all the secrets with Chrome, cookies and passwords and all that. So one note before I let Cooper take over. With Internet Explorer and Edge, the cookies, yes, they're in plain text. It's not hard to get access to them, but there's not a lot of support from a tool-wise standpoint to get access to these cookies. There is a Metasploit module, and it works, but it doesn't work with Edge. And there are some other non-open source products that you can use to recover these, but I don't like recommending them because I don't know what's going on with them. I haven't taken the time to reverse them, so it's just questionable. So the only one that I can, in good faith, say to use is the Metasploit module. We will be including this in the tool in future, but I'm going to shut up now and let Andy take over.
No, it's okay. So a lot of what we've done here is combine a lot of these different techniques that we've seen and put them into a single place because a lot of them are all over the place and you don't really, you have to know where to look to find them and do each individual thing. That's okay, but it's nice to have it all in one spot. Go ahead and hop. So cookie dough here is kind of our just generic, take all the cookies from a system and put them into a file that we can actually use it from. Both of the two major modules in this are split up to where you can either run them on their own or you can use them inside of your own actual software as well because they have a Python, or they are their own Python class, and so you can use them as a module separately. And you don't have to use it only our way or anything else. Basically, what it does is it takes all the stuff from your system, puts it into a variable called cookie files, and then zips all of those files up and puts them inside of a zip file that you then want to feed over to the...
One caveat, though, before we do that. With cookie dough, yes, most of it is just gathering cookies. It doesn't do anything with it, and it doesn't decrypt it. There is one exception to that with the decrypt Windows Chrome, and that's because, as I stated earlier, to decrypt, you need to be running that process within the context of the user, so it has to decrypt on the system.
Yeah, so you have to do it there because you can't just grab the secrets and run, unfortunately. Additionally, though, for Windows, like it shows at the bottom, we've actually got it to a point where it will use PyInstaller, so you don't have to make sure that Python's on the system. You can just load that absurdly large executable up there and then run it, and then grab your zip file from there. Cookie Sheet is the other actual module here, and what it does is take all of those cookies from your actual zip file that you put together, or if you're using any of the load browser cookies, you can load it from an individual file that you've got from any of that and shove it in there. And it puts it together into an array that you can then dump out into a set of JSON files that you can interact with from there. So you can actually see the cookies and deal with them. Anything else on this one?
No.
Okay, yeah. So we can kind of show you a demo of what's going on there real quick. As you can see here, this is basically what you get whenever you pull down the actual repo. You get the cookie dough, cookie sheet, there's a keychain dump, and the cookiedough.exe. That actually matter here. In a second here, we're going to start typing and run cookie dough to show you kind of that it doesn't really show you anything.
That keychain dump also works on Linux to dump the keyring,
yeah.
Just FYI.
Yeah, so it's not just a Mac keychain, it grabs
Should probably
it all. So it gives you basically nothing except it generates that cookiedough.zip. And that contains all the different cookie files that are on this system. From here, since I know that we're on a Mac system, I'm going to go ahead and run the keychain dump, which is going to actually pull that keychain for us. Normally, this is going to show us a bunch of clicks that you have to go through, but right now we're just bypassing that. Also what this does is generate this k.zip that actually contains your keychain. You do not have to unzip this, but I just want to kind of show off that you're seeing the actual raw data from the keychain here. And this is really kind of what it looks like. And you can go through and see, I've got Burp there, I've got some other things going on.
It looks like a bunch of junk, but there are actually plain text passwords living in there.
Yeah. Here we're just going to go ahead and run the cookie sheet, and we're just doing this blank, letting it do its thing. And it's going to run for a second. I'm fixing that error or warning. And then in a second here, we should get a list of the actual browsers that come up, and then we'll kind of go through some of their cookies as well. So yeah, see, we've got here, you can't see Chrome because it's off the screen, but we also have Firefox and Safari on there. And we'll check out the Safari cookies real quick, and then jump into kind of the next cool thing that goes along with this. So it's, you see this gigantic JSON array of all the different cookies that are inside of Safari there.
All right, so that's great. So now you've got the cookies that have been decrypted. And the question is, what do you do with them next?
Yeah, what do you do with them? The next step here is basically to load it into GNAWS, which is a Burp extension. And what I've done with GNAWS is take it so you can take those JSON files and load them into the session store inside of Burp so that you can seamlessly log in or use other people's accounts and things from your computer just having their cookies. So you don't need their passwords, you don't need to log in. You just need to take the cookies, put it in here, say go, use them, and then turn it off whenever you're done.
So
and we've
can
got a
actually
demo
see
for that as well. What we're going to do here is start off by showing you, this is my computer that's got my stuff on it. We're going to go to GitHub, show you, hey, look, this is my account. We'll go to a page that shows that it's a little bit more my stuff, which are the settings. You see, obviously, there's my profile picture and all this other stuff. And we're going to go to a website that I go to all the time, obviously, which is JCrew. And see what
Obviously,
I have.
that was me, but
No actual sign in here where it says sign in. What I'm going to do now is take a file from Kara's machine that she's passed over to me. But first thing here is you've got your Burp extension that you've loaded. But you have to come into the project options here, go to sessions, and then actually edit your cookie jar here, come into scope, and tell it to use it as a proxy as well. Because if you don't do that, it'll never load it in, and you don't get the seamless session integration. But at this point, it's basically as simple as loading the cookies. And in this case, I think, yeah, Chrome cookies is what we're going to grab. And there will be more information here eventually. But at this point, we're just going to refresh these pages. And you'll see that we are now all of a sudden inside of that previous GitHub account that we were in. And we're no longer inside of ours. And then we can also jump back over to JCrew and refresh that. And you'll see it's got my account instead of sign in there. And we actually have a legit account here going on.
JCrew just has a thing where if you've let the session go for so long, you have to re-authenticate, but you can tell.
And I just
who it
reset the
belongs
cookies
to.
there. And what's going to happen is you'll see that we no longer are signed in up in the corner. It's still going to have that email address because it just does. And then we refresh on GitHub and we're back to our original session as well.
So it doesn't actually pollute the session that you already have going on. It keeps them separate,
Yeah,
which can be quite convenient when it comes to
I think it's convenient.
testing. Well,
But
obviously,
like it
it's
says
built in.
there at the bottom, you got to set the proxy flag for the cookie jar use. And you also need to set up your birth certificate for your local machine because HSTS is becoming a real thing and it's a problem if you don't do that. It's embarrassing when you don't realize it for multiple hours as well.
Wait, does that really happen?
No comment.
Sorry.
But
That's
at this
funny.
stage, all of your cookies and your sessions and your life belongs to us.
All right, so takeaway here is Cookie Sheet is your one-stop shop when it comes to getting all the cookies. You don't have to search anymore on the web. Yes, a lot of these scripts exist, so that's not new. The new thing here is GNAWS. But Cookie Sheet does make your life just a little bit easier because you just have to use one script instead of, 5, 6, whatever. Definitely, if you are using this on a pen test, remember to clean up behind. Don't leave any binaries or executables or scripts laying around or cookies or dumps. But yeah, so use that and own all the things. Any questions? Yeah.
You said we could take a look at these slides?
Yeah, absolutely.
Yeah.
Yeah, we'll have it posted. We're going to have it posted on this account here,
Yeah, we'll probably stick it on the wiki
Yeah.
in there. Yeah.
so you can get access to that with the tools.
Next slide.
Oh, you want to see the next slide? For our information? I can go back to that for you guys that want it. Anyways, that's how, Twitter emails us.
Twitter's the best way to get a hold of either of us, basically.
Yeah, don't email me. I never check my email. I'm really bad about that.
It's terrifying.
Sorry, did you guys want me to go back? I can go back. You do? Okay. It's like you moved too fast. All right. Thank you very much.